there, my name is Dr. May. In this video, we're going to be looking at sequences. Now, you may be asking yourself, what is a sequence? Well, a sequence is just an ordered list of numbers that many times shows a pattern. For our purposes in this lesson, our sequences are going to show a pattern, and we're going to be looking for one of two different types of sequences. So let's take a look. We have an arithmetic sequence. And what that means is we're adding something to each term to get the next term. And it's the same thing we're adding each time. So for instance, in our first example, you can see that we're adding 3 plus 5 gives us 8. 8 plus 5 gives us 13. 13 plus 5 gives us 18. So we're adding 5 each time. That is indicative of an arithmetic sequence. Now, if it's not arithmetic, what you can see is 24 minus 12 would give us 12, but 12 minus 6 would give us 6. So we are subtracting something here, but what we are subtracting is changing each time. So in order to be an arithmetic sequence, you've got to be adding or subtracting the same thing every time. So let's look at these. Let's see if we can decide which of these are arithmetic. So on the first one, I want you to see 4 plus 4 would give us 8. 8 plus 4 would give us 12. 12 plus 16 would give it, 12 plus 4 would give us 16. So yes, this one is arithmetic. What about the second one? 1 plus 2 would give us 3. 3 plus 2 would not give us 7. So that one's not going to work. How about the third one? 2 plus 7 gives us 9. 9 plus 7 gives us 16. 16 plus 7. Yes, that's adding 7 every time. Okay, what about the second, or what about the fourth one here? 1 plus 0 gives me 1. 1 plus 1 gives, okay, so we changed what we're adding each time. That's not going to work. 1 plus 1 would give me 2. 2 plus 1, not 4. So this one is not going to be arithmetic because what we're adding is changing each time. Let's look at the next one here. 13 minus 4 would give me 9. 9 minus 4 would give me 5. 5 minus 4, good. Remember, we can add or subtract and still be arithmetic. All right, let's look at this one. 11 plus 6 would give me 17. 17 plus 6 would give me 23. 23 plus 6 does not give me 30. So you got to check them all the way through. Make sure that rule that we're adding the same thing each and every time. Okay, just a few more here. 29 minus 9 would give me 20. 20 minus 9 would give me 11. 11 minus 9 would give me 2. So yes, this is arithmetic. Okay, so 3 plus 6 would give me 9. 9 plus 6 is not 27, so that one's not going to work. All right, 0 plus 1 gives me 1. 1 plus 1 does not give me 3, so that's not arithmetic. And then 11 plus 4 would give me 5. I'm sorry, 11 plus 4 would give me 15. 15 plus 4 would give me 19. 19 plus 4 gives me 23. That's arithmetic. So that's how we can tell if they're arithmetic or not. Are we adding or subtracting the same thing every time? So let's see, when we know that it is arithmetic, we can find what's called the common difference. And the common difference is that value you're adding or subtracting every time. So let's see on this first one, what is it we're adding each time? So 4 plus what would give me 8? 8 plus what would give me 12? And that's 4. So my common difference here is 4. Okay, 2 plus 7 gives me 9. 9 plus 7 gives me 16. So my common difference is 7. Okay, 13 minus 4 gave me 9. 9 minus 4 gave me 5. So my common difference, watch this one here, -4. I had to do negative because it was subtraction. All right, 2 more. 11 plus 15 gives me 4. 11 plus 4 gives me 15. 15 plus 4 gives me 19. So that is my common difference is 4. Okay, last one. 29 minus 9 would give me 20. 20 minus 9 gives me 11. So I've got it. My common difference is -9 there. Remember, negative because I was subtracting each time. So well done. Common difference, it's that value we're adding or subtracting each time to get the next term. Ooh. Okay, so let's see. I've got one building block, then I've got 3 blocks, then I've got 5 blocks, then I've got 7 blocks. What if I wanted to get to the 67th figure? Oh my goodness. I would have to, that would be a lot of adding 2 each time, right? So I think one of the better ways is, what if we could come up with a formula? What if we could come up with a formula that would help us, just like we could put a 67 in the formula and it would tell us how many blocks there are? Well, you're in luck. There is a way to do that. Let's take a look at that. We can use a formula to find any number in the sequence. All we need to know is the first term and the common difference. Remember, the common difference was that thing we were adding each time. Okay. Now be real careful because this formula can look confusing, but I want you to see exactly what it is. It's saying, okay, so we're going to say A with a little n. We say that A sub n is equal to the first term plus parentheses n minus 1 times the common difference. We're going to put all of those, we're going to put values in for most of that, and you will be able to use it. Now, here's the good catch. You don't have to memorize this formula. It's totally available to you on formula charts. You do definitely want to have it in your notes so you can reference it. And you probably want to have all these little labels here, like, so it tells you that that A with the little 1 is the first term. Let's put this formula into good use, though. Okay. So here's our same problem with the blocks. We want to write a formula for it. So all we need to know is the first term. Well, the first term we were told 1 block, right? And then we need the common difference. So what is it I'm adding each time to get the next term? So remember, we said then it was 3 blocks and 5 blocks and 7 blocks. So my common difference here is 2. So let's put that in our formula. A with a little n equals A sub 1. Remember, that's our first term. So that's a 1 plus, now here's the thing, you're going to leave that parentheses just like it is, parentheses n minus 1, and then times the common difference. The common difference was, what was it we were adding each time to get the next term? And that was 2. And that's my formula, friends. I know it looks crazy. If I wrote it with the little subscript, so let me write it with my pen here so it'll show up a little bit better. A sub n equals 1 plus n minus 1 times 2. And that's it. That's my formula. So now if I want to know the 67th term, I'll just plug in 67 for n. I'll get 1 plus 67 minus 1 times 2. And order of operations, I can totally figure out what that is. Okay, let's practice with this formula because I think it's going to help you a lot. So some arithmetic sequences are given here. We want to find the first term, the common difference, and then the formula. Okay, so let's do that. We'll look at this one. Our first term there is the first one listed, -3. Now, what is my common difference? What did I add or subtract to -3 to get -9? I subtracted 6. That's right. So my common difference is -6. So I'm going to write my formula like they did with a capital A of n equals, remember it's first term, remember first term here, A sub 1. So that's my -3 plus parentheses n minus 1, and then times my common difference, which is -6. And you're not seeing that because it's going off the screen there, but there's my formula. Okay, let's do another one like that. We can even do it with fractions. Okay, so my first term is 1/9. And then my common difference, so what did I add to 1/9 to get 1/3? Same thing I added to 1/3 to get 5/9. Same thing I added to 5/9 to get 7/9. Well, that's a little easier to see, right? Because in order from 5/9, I would have to add 2/9 to get 7/9. So my common difference is 2/9. Let's write our formula. A of n equals first term, that's my 1/9, plus my parentheses, n minus 1, times my 2/9, common difference. Okay, two more. Let's take a look at this next to last one. My first term is 11. My common difference, I subtracted 4 from 11 to get 7. Subtracted 4 from 7 to get 3. So my common difference is -4. My formula then is A of n equals, first term is 11, plus parentheses n minus 1 times -4. All right, last one. Okay, so my first term is 13. And then I add 13 plus 8 gives me 21. 21 plus 8 gives me 29. So my common difference is 8. I can write my formula then. A of n equals first term 13 plus parentheses n minus 1 times common difference is 8. We did it. So here's the deal, friends. Your formula is the same pattern every time. If you can identify the first term and you can find the common difference, you're set up to find this formula. All right, now let's use the formula. All right, so here's a problem that we would have to use a formula for. So if we have a theater, it represents a arithmetic sequence. So there are 17 seats in row 1, we're told, 20 seats in row 2, 23 seats in row 3, 26 seats in row 4. Sounds a lot like an arithmetic sequence. Hint, hint. What is the common difference? It's 3, right? We add 3 seats every time. Okay, so we want to know how many seats are there in row 15. Well, we can write a formula for that, can't we? We're going to say we need the first term. First term was 17. The common difference we know was we added 3 every time. And so just like we did before, we're going to write that formula. First term plus parentheses n minus 1 times common difference. Now we want to know how many seats are in row 15. So the beauty of this, we get to plug in 15 for n. And we're going to solve. Now, order of operations tells me I have to do the parentheses first. So I have to do 15 minus 1. That's 14. And then I have to multiply, right? 14 times 3. And that gives me 42. So I have 17 plus 42. And now I know there are 59 seats in that 15th row. That was a lot easier than having to count up to row 15, wasn't it? And remember, the beauty of our formula is I only have to know the first term and the common difference. That's it. I love that. I love that we used that formula. It made it so much simpler. So another way we could do that is to represent the row number as the X value and the seat number as the Y value. So if I have row 1 and there are 17 seats, you can see that row 1 would be here, and I need to move this to 17 seats. Row 2 has 20 seats, so I'm going to move that dot there. Row 3 has 23 seats. I'm going to move that dot here. I'm going to take row, oh, forgive me, these are going by twos. So let me make sure I get them in the right spot. There we go. There we go. Row 4 has 26 seats. That would be here. Okay, so what do you notice about the relationship? I hope you're noticing it's making a line. Yeah, exactly. It makes a line. Oops, if I can get my dots in the right spot. It does. It makes a line. And since we've been working with lines in our class, I think this is a nice little connection we have. Okay, so you'll notice that all of those points seem to fit really nice on this line. And that's because arithmetic sequences are functions and they do form lines. All right, so let's do a couple of problems to see if we can notice a little change in the formula here. So I want you to see that the common difference can go before the parentheses, the n-1 parentheses, or it can go after. Either one is okay. So let's see if we can write one where the common difference is going to go in front. Okay, so notice our sequence here. 23, 13, 3, negative 7. So remember, in order to write our formula, we need the first term and we need the common difference. So the first term here is super easy. That's the 23. Common difference is, notice we're subtracting 10 each time. So we can do that. So let's write our formula here. So my first term, my a sub 1 was 23. And my common difference was negative 10 because we subtracted negative 10. Now, previously, we would have written that as the 23 plus the parentheses n-1, and then we would have multiplied by negative 10. What we're saying now is, hey, you could write that with the negative 10 in front of the parentheses. And you'd be right. Okay, and so the one that would have to be correct here would be this one. Notice it, we just move the negative 10 in front of that parentheses and we get the same thing. Okay. All right. I got one more practice problem as we finish up here. So notice in this one that we are told something different. We are told a sub 3 and a sub 4 and a sub 5. So here's what that means, my friends. That means there is a sequence, and the third term is 0, and the fourth term is 6, and the fifth term is 12. You catching my drift here? That's what they mean by a with the little 3. They're saying the third term in the sequence. Now here's the problem. We can't write a formula unless we know the first term. But you and I are going to figure that out, because watch what happens. So what's the pattern in this formula? The pattern here is that we add 6. So let me ask you this. If I added 6 to this number and I got 0, what was this number? Think about that. If I added 6 to it and got 0, then the number had to have been negative 6. Because negative 6 plus 6 is 0. All right, well, let's use the same logic for this number. This number plus 6 got me negative 6. So this had to have been negative 12. Now I know the first term. Okay, let's use that then. So the first term is negative 12. And the common difference, we already said, was 6. So let's put it in our formula. A sub n equals first term, negative 12, plus n-1 times 6. Now, you'll notice none of my answer choices have any parentheses in them. That's because we know the distributive property. So let's use it. I'm going to distribute this 6 to the 1 and to the n. Okay, so that's going to give me a sub n is negative 12 plus, now distribute, 6 times n is 6n. 6 times 1 is 6. We're getting closer. Yes, so now we just need to combine like terms. Negative 12 and negative 6 is negative 18. And I've got that 6 in there. Now I can see that it should be this formula. All right, my friends, that was bringing it all together. And I wanted you to see that type of question because I think it's a really good one. I hope this lesson has helped you know that really sequences are just patterns, but we have a little bit of notation with them. We have a little different terminology like first term, common difference, all of those good things. But thanks so much for watching. Leave me a comment down below if you have questions, you want to see more videos like this. Bye, everyone.